Okay, I'm gonna start kind of quiet because reminder, the music's way quiet. I probably need to set the music at like one level for the intro, so hopefully I'm not blowing out anyone's ear. But good morning. It's day three, week one, day three of Ergot stuff. I'm wearing my rest embedded shirt to represent. But yeah, how's it going? Let's see. Yesterday we talked a bit about a bunch of these like use cases and like some of these topology things and some like feature things. This is kind of what I got written up yesterday. I think my plan today is probably audio's good this morning. Good. My plan today is probably to keep working on this, to maybe turn this into like a page in the docs of explaining just why you might want to use Ergot for all of these things. Maybe if I think of some more to flesh out, I can flesh some more out of these. Had at least one discussion go up. Let me find... Close my window. I did close my window. Alexandra. Yeah. Alexandra had an idea of making the network generic. So this would be a way to support larger numbers if people are interested. I think that is interesting, and Alexandra nails the issues that this ends up sort of making them incompatible protocols. Actually, it's trickier than that. So let me... The answer is actually not as breaking of a change as you think, but is still in some cases a breaking change. So talking about addresses, normally, like I said, addresses, sort of like the thing that describes what the machine is the network ID, which is what network segment you're on, and then the node ID, which is an 8-bit quantity. So essentially you've got like 24 bits of device address, more or less. The funny thing with this is when this gets put on the wire, currently it gets turned into a U32, like a 32-bit integer, with the net ID being the most significant and the port being least significant, and then gets variable length encoded using varants like Postcard does. So, well, yeah, that would probably break things. I don't, because it only gets encoded as a single variant. Yeah, okay. I'm probably back. You were probably right to begin with that it makes it incompatible. It's an interesting idea, especially because it is meant to be more of an ad hoc protocol. It does seem a little foot gunny to me, but I'm not against it. I think probably what I would say, my funny answer to this is I think this is a good idea, and I think this is a reasonable way of doing things. I've been trying to get rid of as many generics in NetStack as possible, but this is a very reasonable way of setting this. I guess I want to know the first time that someone either has more than, so I mean if the net IDs are, or excuse me, yeah, the net IDs are 16-bit and the node IDs are 8-bit. I want to know the first time someone has more than, so this is like 65,000 because these aren't signed numbers. So this is up to like 65535 network IDs, or 34. I don't know. I exclude some, and 254 node IDs. So the first time someone has like more than 128 nodes on a network, or more than 32,000 network IDs, and like in a real thing that you're doing, and not just like, haha, I have spun up so many threads. Let me know, because at that point, like, I don't know, then we could talk about it, or maybe like a quarter even would be interesting. But yeah, I think having this, I think this is a reasonable idea. I'm not going to touch it now, honestly, just because stuff's still going to get changed. So, reasonable thing to think about if we were to get to a 1.0 state. And I think definitely reasonable to talk about how we would handle, hey, how do we handle success of like someone has way more nodes or network segments than I think. I think that's a very reasonable. I'm just not going to probably think about it until it's a problem or until it's like closer to a problem. But yeah, I think this is an interesting way of doing it. And I think you're very right that Ergot is meant to be more like area specific. And it really is oriented more around like, hey, I have firmware in every device that's in the network. I'm not. We'll see if it gets popular enough for people to be like, I am selling an Ergot device. But yeah, I think this is a cool idea. I don't know if it's actionable now, but it is interesting. Sorry for not sharing specific questions in the discussion I opened yesterday. I'm hoping to find some time to get my thoughts together today, but I think the main difference in what I want to learn about from the docs you already have is the message routing. There's a specific system feature I have in mind from Plan 9 called the Plumber, which I have a very simple of implemented in my editor that I'd like to extend. Cool. Yeah, Sminez is probably talking about the Ergot versus Plan 9 discussion. So Sminez shared some cool projects doing a Plan 9 server. I did look into this a little bit. It has a very cool. It's got basically like it's a very reasonable way of doing it. It has like a specific trait that's. I'd have to go find it, but it has a specific trait for. I think this is probably the impl of this. Yeah. So serve 9p where it's got all the endpoints. This seems very reasonable to me, especially for a file system protocol. I think I saw something similar for someone wrote an NFS driver in Rust, and they were using it for because basically they said that I forget what the Fuse, the user space file system stuff, is like not super well supported, especially on Mac. Like on Linux it works fine, but on Windows it's kind of weird, and on Mac it's kind of weird. Whereas NFS I think has a much wider level of support, if I'm remembering this correctly. So there are folks who have like, okay, cool, just for analytics, we'll just present that as a file system, and then you can like poke around at the command line and use that as instead of like a REST API, you can browse around your file system by making a network file system, which is pretty cool. I've seen some other stuff do something similar like that, but I just haven't had a chance to mess with it, but it does seem very cool. Their varants, can it just be handled by the router? I'm not sure what you mean, Remrevo. There could definitely be something that bridges, like it knows one side speaks classic 32-bit addresses and the other side speaks like 64-bit addresses like that. There's definitely some like translation you can do. You'd have to define. It's like defining 6 to 4 in IP and things like that. Yeah. Oh, hey, Alexandra. We talked about you, hopefully, or, yeah. I don't know if you have a chance to go back and check that out. But yeah, we mentioned a little bit about the proposal you had, and it does seem reasonable. I don't think we're there yet, and I probably wouldn't mess around with it today. But like I said, if we start getting to the point where people have that many devices or that many network segments, then we should probably talk about it. And it's a good, like, your proposal is generally very reasonable. Yeah, NFS is what WSL uses. That makes sense. Yeah, NFS just seems like it has, I'd have to go find that. Let me go find that. Rust NFS library. Yeah. The library is called NFS Serve. And they have a good blog post that explains like why this. It's a pretty good read, and it seemed pretty cool. Like I don't know much about NFS, but it has a very similar sort of trait where it's like there's a trait. I think theirs has like way more methods, but it's like, okay, you just fill in the ones that you can, and then any ones that you don't, it either returns none or does something, or like you should make it return this. But it seemed interesting. Like it especially if you don't want to make a user interface, using the file system as a user interface seemed like a fun idea to me. I thought it'd be fun to do analytics or something with that. And I've never tried to implement Fuse. So, but yeah, Plan 9 I think is the same neighborhood of NFS, although I'm sure that makes someone upset that I said that. But they're both remote file system protocols, which seems interesting. Yeah. Don't think there were any other open questions. I'm gonna be here for at least the 15 minutes. And then if other people have questions or they want to share stuff, I think that'd be really cool. If someone gets stuff going and wants to share it, that'd be cool. Like I mentioned in the docs that I was writing up yesterday, you can totally run this. You don't need any hardware in particular. If you want to play around with it, you definitely, there's in the demo repos, there's the stud demo repo. Let me just show running that in case someone feels inspired to run that. So, man, this is probably gonna make my editor freak out. Pull GitHub main. Let me make this bigger because I think that was a problem the other day. So if we go to personal Ergot demos stud, cd demos stud. So like the simplest example that I have is the, let me open my editor for this. We'll get back to this. We'll run it first, but so we can go to the Ergot router and we can do rust log equals debug cargo run release, and then in Ergot client I can do rust log equals debug cargo run release. So we have kind of two roles here. We have the router and the client, and this is using exactly where my it's exactly this style where you have a server process that opens up a TCP socket, any client that connects to it. These each become like a 2-device point-to-point network segment. So this would be like network segment 1, then 2, then 3, and these become like 1.1, 1.2, 2.1, 2.2, 3.1, 3.2, and then they can ping each other. And the demo, like they all just kind of like ping and send logs and stuff. So you can see this one is like in the router is looking up what nets it knows about, like what active connections it has. So right now it has none. I actually probably should, let's get another third window going. cd personal Ergot demos stud Ergot client. Okay, so we have nothing here, and if we run this, we can see it starts. We say that it connected a thing for here. All right, now this is way too much logging. The important thing is you can kind of see it doing these pings. So it's saying I'm pinging device 1.2 with, it's just an incrementing number, and we got back the same number. So we ping with 5, we get 5 back. We can see over here that the device is getting items. I think it'll probably say like serving ping 7. So we can see that like when this says 8, it's serving that ping number. If I make rust log equals debug, let's just do info here. Cargo run release. We can see that it's also pinging now 2.2, and this is probably just too many messages, but we can probably see it doing 1.2 and 2.2. If I spawned up a bunch more, it will handle it up to the 65,000 limit, or at some point it'll freak out probably. But if one of these nodes goes away and we stop, it will notice that, and we see there's a disconnection there, and we can see now that it's only pinging net 2 because that's gone away. If we start this back up, we can see that it'll reassign net ID 1. Like right now, just my net ID allocation code does this. Yeah, and there's also some other stuff going on, like there's these broadcast messages. So in the demo code. We could look at that real quick. And I should probably look at chat, but the router basically spawns. It binds to this port. It starts a new router stack. This one's interesting because instead of a static, it's this router stack type is like an arc net stack. So it has it's using an arc because we're on desktop and we can. So it spawns a task called ping all, which basically every 3 seconds it grabs the list of nets that our netstack knows about, or our profile specifically knows about, and then for each of them it sends a ping. It knows that it's in the setup, all of the nodes are going to have address 2. All of its direct connections are going to have address 2 because they're point-to-point links, and so it pings them with a timeout, and then it just prints that out. It also spawns 4 Yeet listeners. Basically, I just made like a very simple topic. This is one of those broadcast topics, and it just prints numbers. And then when we look at the client, it's fairly similar. It runs a ping server instead of a ping client, so it's listening to incoming ping requests on that same endpoint. Whenever we get a U32, we echo it back and we kind of print that we got it. And then we have these yeeter tasks, which just send a broadcast message, which is just a number. And we have some local listeners. And if we were to really look at the logs, we can see that when we send this broadcast message, it gets delivered to, I guess I spawned 4 tasks for some reason. So all 4 of them will actually hear it locally. But then also the one on the router will hear the exact same thing because it's broadcast. And when you have multiple nodes, they'll hear each other's broadcasts. So, like if you have 5 of these clients, both the router and all the other 4 clients and the device that sent it can all hear this because they're all listening to the same socket. And these broadcast topics that I have will just send it everywhere. I think it has a time to live of 16 hops or something like that. I forget what my default is, but it'll just keep propagating until you basically run out of places to go or it's hopped too many times. Now I'm looking back through chat. Ooh, I was thinking about doing email as file systems. NFS might be an easy way to do that. Yeah, I think Plan 9 or NFS were both interesting for that. There's a lot of Plan 9 enthusiasts out there. But yeah, it's... if you want something that works on all 3 platforms today, just like out of the box, NFS might be better. Sorry, Sminus. But if you want like a more excited group of hobbyists, then Plan 9 might be the thing. Definitely want to at some point. I need 5 to do it. Alexandra asked about error correcting. So I guess the question is error detecting versus error correcting. So right now we don't actually have a dedicated checksum. I don't say every frame must have a CRC16 or CRC32. Mostly, I don't know. I have mixed feelings about that. That's probably worth a discussion if anyone has feelings about that. It's a downside because it means that right now what I say is basically if you're sending it over a lossy medium like a serial port or something like that, that's something that you should add at the interface level. So in our, if you have, for example, something like this, if these are serial ports, you might want to define your serial ports to have a checksum in them because serial ports are lossy, whereas USB already has, I think, a CRC16 as part of the wire. So it's interesting because an interface like USB already has some things like retries and error detection and stuff like that that's transparent to the user. So it'd be kind of silly to build our own on top of that. It's kind of wasted space and effort, unless we need stronger guarantees. But Over things like a serial port, it's not. Like, you have nothing. So it would be good to have it there. So what I've said so far is basically it's a property of each connection of whether it should have additional checksums and stuff like that. But there's also a value to make sure that your message made it all the way to your sender and destination and back, because the less you trust all of the nodes along the way, the more you want to have like an end-to-end checksum. So I don't know. I'm kind of squishy on that. If people have opinions on that, I could probably stand to have like a CRC16 built into the protocol itself, or even something like a CRC8 for the header and a CRC16 for the body. I don't know. I'm open to that. I just haven't had strong opinions, and so far I haven't really been using that lossy of a connection. I have fairly ideal lab conditions here, so yeah, I don't know. That's what I'm mushy on. Error correction is a whole other thing, and I have done that for other things like radios, where you have you send additional data so that you don't have to worry about resending. So what you might do is you say, okay, like a way that it commonly works, like if you had like a 64 byte message, you might do something with like fountain codes or something like that, where you send an additional 10 to 100%. So instead of it each message being 64 bytes, it's anywhere from like 70 to 128 bytes, depending on how much overhead you want. And you do some clever things where if you lose part of this message, you can recover without resending the message. This is really useful in things like LoRa or LoRaWAN, or like any long-range radio or satellites and stuff like that, where the latency of asking for a resend is so much higher than the overhead of sending double. So like sometimes it's easier to just send 128 bytes of data, because you're kind of like doubling your chances of success, maybe more than doubling your chance of success, because if there's like a 1 second latency for requesting responses and things like that, this is going to make everything run way, way faster. So that's like error recovery or things like that. But the downside is you're always adding that overhead for every message. And so if like you have a fairly reliable medium, like something that only drops 1 out of a million packets, then you're paying 10 to 100% overhead on everything for that. Whereas on like low latency connections, like a serial port or something like that, it might be better to have just error detection, like a CRC, because that way if you get a bad piece of data, you can just immediately say, hey, resend that. That was bad. And that's an option. But yeah, there are cases where like that latency is not worth it, or like storing the extra data is not reasonable. And so it's easy to just like programmatically calculate this and send out twice as much data or even more. Like that's what like satellites do, is they just go, okay, well, I'll just send out a bunch of extra data because my round trip latency is 8 minutes. And so if you have to request that, it's going to take, 3 round trips, like the time, the timeout, the request, the response. So like instead of 8 minutes, it's 24 minutes. So, hey, actually sending double the data is just not so bad. But yeah, error correcting is interesting. I'm more likely to do error detecting than error correcting right now, because at least as far as I know, no one's using this over very high latency links. If you want to use Ergot over a satellite link, let me know. We'll figure out how to do like fountain codes or raptor codes or things like that. That'd be very cool. But yeah, I think it might be more reasonable to do error detection like CRC16 at some point. Because it's not totally unreasonable, and it like, yeah, I don't know. The other thing that I'm like, yeah, I don't know. I want to avoid extra overhead or like pulling in a CRC library if you don't need it. Like if you're only doing local connections, or if you're only going over USB where it's not super necessary. Like it's a little extra to have it. So I don't know. I'm just waiting for someone to basically make I'm saying right now the answer is no CRCs. But I'm telling you, my opinion's pretty weak on that. It would probably take the first person saying, "Hey, no, we should have a CRC 16," and I'll go, "Okay." So basically, when someone steps up and has that argument, I'll figure out how to do that. But until then, I'll just keep messing around. But yeah, I think someone already mentioned it. Like Firecracks is the one that prompted me to have this like device to device UART link, and that's a case where clearly you would almost certainly want to have some kind of CRC. But then the other thing that I'm kind of saying is that until we have this session full sockets where it makes sense to retry stuff, well, I don't know. We don't want to get bad data. I was going to say until you can resend it, there's no point in having it, but that's not true. Just throwing away bad data is a good idea. Like, unmarkedly better idea than not doing it. But yeah. Haven't seen any chat messages for a second, so I'll kind of give a couple minute warning. If there's no more, then I'll probably go and keep fleshing this out. I would love to have someone open up a PR or like have something to share, show and tell. So even if it's just getting the example running or extending it or playing around with it or using it for something, and you know, I don't know if today is reasonable for folks. I imagine people have stuff to do. Maybe over the weekend, like Monday would be a really cool day for show and tell. So if you have some time over the weekend, that'd be cool. But yeah, if anyone has anything to show or tell, or yeah, this is funny because these can just keep going. Boop boop boop. Yeah, I'd love to show and tell. If you get this working, even if it's just, hey, it's working on my Pico and I'm excited about it, that'd be cool. Yeah. Otherwise, I hope everyone has an excellent day. I'm going to keep working on docs. My goal is to, like, hopefully, ideally not touch a lot of code this week and just really focus on docs. And, someone did suggest adding the link to the matrix on the README. So now on the README, that is there. And also a link to all the streams and stuff, or at least my channel on YouTube and what time we have those. So, yep, hopefully we get more folks in. Turns out Linux just has a Plan 9 kernel module. Yeah, that does not surprise me. That makes a lot of sense. If there was ever going to be something that had it, it was going to be Linux. But cool. So hopefully people can find us. We're kind of crashing the Namas room. I eventually plan to use Ergot for Namas. If it gets annoying to other people who are like, hey, I care about Namas and not Ergot, maybe we'll end up making our own matrix room. It's not a huge cost, but I also, like, I don't want to have a lot more rooms for no reason, especially if one is very, very quiet and one is not, because it just means I have to keep copying stuff over if it's relevant. But we'll see. Maybe we'll have our own room. But for now, we're going to crash in the Namas room, which is my my operating system project that I work on with some of the folks that were in chat yesterday. Like Anatol was in chat yesterday. Eliza wasn't, I don't think I was ever in YouTube chat, but is in a Matrix chat for sure, working on Namas. But like I said, Namas got derailed because I needed a communication system, and Ergot is that communication system, it seems. So we'll get back to it. Maybe create a space. I have no idea how Matrix spaces work. I don't think my client supports them. You're very reasonable to suggest that, but it is a feature I don't know has wide support on Matrix clients. If it's just my client that doesn't support it, then that's a bummer. But yeah, I probably won't. I'll probably just make rooms and add links to it. So reasonable suggestion, Remrevo, but probably no. If someone else wants to create it and add it as a link, I'm happy to add it as a link, but I don't really use spaces. I think Embedded Rust has a space as well, and I just never use it. Okie dokie. Well, I'm going to go work on some more docs. I hope everyone has an excellent day. Soliciting show and tell items if people have questions or thoughts. If we want to move any of these design questions over to discussions, if you see something that's interesting, just let me know, and I'll kind of move it over to discussions if we want to talk about it, because I have a bunch of my, like, some of the stuff that are mentioned is eventually here, and then just some, like, hey, I need to figure this out. So there are some issues there if you want to peek at it. Maybe we can go over those, but yeah, I'll probably wrap up for the day. It's been excellent chatting with you all. I hope to see you again in the afternoon. Again, we're gonna do this about 8 o'clock. We'll do a wrap up, and yeah, we'll see what I get done. Have an excellent day, everyone. Talk to you all later.